Welcome to my feedback to week 4 of the GeoMOOC. Week 4, which was dedicated to how sediments are produced, transported and distributed. We have had hundreds of participants, hundreds of you are working hard on the assignments, are working hard looking at videos, and are also working hard in giving posts and feedback. While we appreciate obviously the compliments which you make, we are very much interested also in your criticism, which we will use to improve the next edition of GeoMOOC. The first issue which I would like to highlight now is that of sea level changes and of factors controlling the deposition of sediments. There is some group of people who think that sea level changes and tectonic movements are the most important factors controlling the deposition of sediments. These processes are called allogenic, means that they come from outside. Other people think that autogenic processes, which means the inherent processes of sediment distribution, are at least as important. The cliff, the nice mountain which you see in this picture near Asaka in the Atlantic coast of Morocco, shows a nice example of these issues. Here in the lower part of this section, you see a lot of shales, a lot of marls, fine-grained marine sediments. And then when you ride to the cliff here, you see some sands which were deposited by a river, by a delta arriving into the sea. And then we start again with marine shales. Why did this intercalation occur? Was it climate change? Was it the river arriving? How does this work? The second fascinating issue is that of deep sea sedimentation. There is apparently much more going on than slow, continuous background sedimentation. Sediments stored in the continental shelf become unstable at times, and then they rapidly, catastrophically go down the slope and invade the abyssal plain. Funnily enough, you see that in the slope and in the upper part of the abyssal plain, they can form channels. This is a seismic cube. You can see that they form channels and meandering bars, meanders which look very similar to the ones you see at the surface in alluvial plains. And here we might be at 3 or 4 or 5 kilometers depth. And what to say about the amazing recurrence of all these turbiditic episodes? What are the factors controlling these? How much sediments is involved in this? How regular are they?